All right, thanks, folks. Thanks for coming. Welcome. My name is Ali. Yeah, I work at Microsoft in the language team, part of the AI research group based in California. So it's about 3:30 my time right now, so I apologize for being grumpy and tired. All right, so just to kind of set the agenda for today, or for the next 25 minutes, I'm going to talk about our new tools that came out as part of the Microsoft AI platform. So there's a bunch of things we released in the last 2 months that are kind of fun and interesting, so I'll talk about that. In particular, I want to talk about how we can develop useful interfaces to these tools and technologies from languages like R and Python, and have them deploy on our favorite environments like Spark, or deploy them on Docker containers so we can productionize them. I'll look at a couple use cases. So first we'll look at some examples of computer vision, and then also natural language processing examples as well. All right. Before we go there, I just want to take a kind of a diversion because it's pretty fun for me to talk about this. Does anyone know who that really cool person is up at the top left? No one? All right, that's Ada Lovelace. So she worked with Charles Babbage on the Analytic Machine, which was one of the first computing systems ever created. And I think it's really cool. It's over 150 years ago, almost 200 years ago. And in the manual for that computing system, she has some really fascinating quotes and ideas that I think are still very pertinent and kind of prescient for where we are today. I know there's a lot of text, so I don't want to read it all to you, but usually I just keep the middle piece of this paragraph. But one of my really good friends admonished me for not having the full context, so I had some more there. So the piece that I usually talk about is right in the middle. She says, the analytic engine has no pretensions whatsoever to create anything, originate anything. Right? So it's not some sort of intelligent system that is creating new or being very creative. It's just sort of doing computations. It's kind of a system that does your instructions for it. But the rest of this paragraph is actually very interesting as well, because she also says at the very beginning, that's kind of prescient today, that it's desirable to guard against the possibility of having exaggerated ideas that might arise as to the powers that are in this system, right? So kind of a warning against hype cycles and believing in something that may not be there yet, all right? And the reason for that is that might create a tendency to overrate what's currently available in that system. And as a side effect of that, you might undervalue the true value of that system, what it can actually do for you. And what I should really do for you, this is the last part that I think is really, really cool, where she says that the real value in these type of systems is to really distribute and combine the truths of the formula in your analysis, right? The real thing you're trying to go for, so that they can be most easily and rapidly amenable to the system that's going to compute on it, right? So describing your data or your hypotheses in the most amenable way for that computing system, so that you can really ask the really deep and probing questions in that application. And so to me, this is really interesting because we have this big potential right now, part of the AI groups and AI research teams, that we can make creative systems that can think and do all these really cool and visionary things. But I think we should take a step back and really think about what is our end goal. Are we trying to ask deep scientific questions? And if we are, we've got to figure out the right way to probe our systems to ask those questions. So I think from the very beginning of the history of computing, there's been a fascination with AI, probably in before computing. There's been all kind of interesting anecdotes of people finding personifications of mechanical systems. But AI has been around for a long time. The last few decades have really seen a lot of growth and interesting applications of machine learning and AI, right? So how we can figure out generalizable methods from empirical data, from what we observe, what we sense, so on and so forth. And as alluded to in the last paragraph, one of the best ways of doing this is to represent our input data, the things that we observe, the things that we experience, into a useful representation so that they can be most amenable and most easily computed in our systems. And I think deep learning is really just one very efficient application of that, where we can automatically generate very interesting features that can help us get insight about our problems. So I say all that because AI is a really, really broad field. So when we say we're trying to create an AI platform, I think we have to be careful about that because it could mean a lot of different things. And just because right now the most exciting breakthroughs are happening in deep learning, we don't want to create a system that's just for deep learning. We want to create a system that will hopefully give light to other technologies that aren't so glorious right now, but may be very useful in the future. but deep learning really is taking over the world everywhere we go. You can't go anywhere without hearing about deep learning. And one thing that kind of caught me off guard was there was this really interesting ad campaign, which I'm sure some of you guys saw this summer by Yves Saint Laurent. So it's a company that specializes in perfumes and colognes. And one of their faces of this ad campaign was this researcher from Stanford University. He's a graduate student at Stanford University. And he was the face of their ad campaign. And they made machine learning look so damn sexy. Like they had this guy, he's a beautiful guy, absolutely gorgeous guy, I admit that. But they made machine learning and deep learning look so sexy. They had Jupyter kernels running deep learning models and archive papers on the floor and all this fascination around it. Which I think is interesting because, just a few years ago, the perception of machine learning researchers or researchers in computing were these nerdy folks that couldn't really do anything cool and sexy. But now it's quite a bit different, which is interesting. Because it does indicate there's a lot of attention and a lot of excitement about the field. And so one way of looking about this is that one of the longest standing conferences in neural networks, the NIPS conference, has been around since the mid-'80s. In the last 6 years, it has grown exponentially. So even in 2011, before an ImageNet competition was conquered by convolution networks, there was about 1,000 folks attending and about 600, 700 submissions. Last year, it was in Barcelona, and there was over 6,000 people attending it and over 3,000 submissions. Just ridiculous numbers. And this year, it's in LA, and there's over 7,000 people attending. It sold out in a few days. People that were planning to attend in the workshops couldn't even sign up because it sold out so quickly. So I think we talk about a singularity that might happen in machine learning and deep learning and AI, and I think this is one singularity that might actually happen. It may not be computers taking over the world, but it might be people going to NIPS that are going to be more than people in the universe. So we have to be a bit safeguarded about that. So all that's kind of tongue-in-cheek, but it is to say that we are trying to create a system, a platform that will enable everyone to really achieve the most out of machine learning, deep learning, and artificial intelligence. And this really has to be for everyone. I mean, there are 3,000 plus submissions to a conference, but the amount of people that could take advantage and leverage machine learning and AI for their use cases is a lot more than that. And we have to enable everyone, not just a few researchers. So the platform that we've released really focuses on many different components, but we really try to specialize in these 3 components here. That's how I like to think about it. So we have services, which include many different products and frameworks. But the 3 core ones are our bot framework for creating conversational agents, so things you can deploy to have interaction with a bot-like framework. I'll show you an example of that at the end today. We also have content services, which are pretty much pre-trained models for many different use cases in vision, in language, recommenders, and all kind of different use cases and domains. So you can kind of take an off-the-shelf pre-trained model for your use case. And then you have the ability to create your own custom service. So if you want to train your own type of vision model for a very specific use case, whether it's detection, whether it's segmentation, you can do that with our systems as well. We also spent a lot of time on infrastructure. I think our first foray into the cloud computing world was based on infrastructure. And I won't go through all the tools here. But I think this is one place where Spark really shines, because it's really proven itself to be a framework that can handle a lot of variety of use cases. And we're going to see out today that it's going to be kind of our glue for doing a lot of different tools and technologies together. On the tool side, we try to enable different systems so it makes it easier for you to develop your application, deploy them into our infrastructure. So we have released a new toolkit for prototyping, experimenting, and deploying models called the Azure ML Workbench. I'll show you an example of that today, which, as mentioned earlier today in a very fascinating talk, a lot of time spent in experimentation. But when it comes to deployment, you have to really rethink your infrastructure and how you can deploy that into a real system and how you can get feedback from it in a real-time scenario. So you spend a lot of time thinking about that as a core piece of that workbench. For folks that want to get started, we also have a sort of web-based GUI framework that's a bit more friendly for users. It's called Azure ML Studio. And we've also developed a bunch of plugins for our editor, Visual Studio Code, to enable you to develop and deploy models through an editor directly. And I really do mean, because there's so many different people coming at machine learning and AI, we want to enable everyone in every framework they enjoy using. So we'll talk a lot today about the Microsoft Content Toolkit, CNTK, but We do want the third-party tools like TensorFlow and Caffe2 to feel like first-class citizens in our environment, right? So everything we enable for CNTK, we want to make available for these frameworks as well, so you can pick whatever you enjoy the most. I'll talk a bit more about that today. So there's a lot of different tools in that system. I'm going to focus primarily on Spark, because we're here for Spark, and how that can be utilized in the Azure ML Workbench for prototyping and sort of deploying models, as well as implementation and model management. So this is a quick little talk about deep learning frameworks. So I'll talk a lot today about CNTK, which is a Microsoft Cognitive Toolkit. It's called CNTK because we have a habit of changing our names a lot. So before it used to be called the Computational Network Toolkit. That's why it's CNTK, whereas now it's the Microsoft Cognitive Toolkit. It's primarily written in C++, and its first main API was in BrainScript, which is kind of a NetSharp or C# type language. But since the 2.0 release, we really focused on the Python bindings. That's kind of the native bindings for CNTK now. And we added support for Keras as a backend, so you can use Keras and switch the backend to CNTK, which works as well. And there's been some very curious folks, I'm guilty as charged, and intern that we had this summer that really wanted to make R bindings for CNTK. So we made some R bindings for that, and we just released as well. This is not ordered any sort of way. I know it looks like that, but I just ordered it out of the 5 frameworks that I find most fascinating right now. One of the most popular frameworks right now is TensorFlow, and we do want to incorporate TensorFlow as a first-class citizen in our environment. The one main difference between TensorFlow and CNTK is that TensorFlow's main API is a pretty low-level API. And it feels like writing C++ or even machine code sometimes. That's why there's been so many other APIs that are written on top of TensorFlow. Actually, all of these are written by folks at Google. So Keras was written first by Francois Chollet for Theano and then TensorFlow, nice part of Google. TF-Slim, TF-Estimators, TF-Learn, all written as contributing packages to Google. Sonnet was developed by the DeepMind team based in London, and a pretty big team now. And Tensor was Google Brain's framework. So a lot of different APIs, but all based in TensorFlow. The second two that I find very fascinating are the ones developed by the folks at Facebook. So Caffe2 is the sequel to Caffe1, and PyTorch is the Facebook AI research toolkit. And they're very fascinating because PyTorch is very different in that it's a dynamic language. So rather than defining the entire computational graph beforehand, you can define things on the fly. So that's what the research team uses all the time. And for production, the data science team uses Caffe2. Which is pretty interesting, and I'll talk about it a bit more in a second. And lastly, MXNet for kind of a mixed net is the naming for that. It also has a high-level API called Gluon, which I'll talk about in a second, and a backend for Keras. So that's just 5 frameworks, but it's already 5 pretty different frameworks. So it can be kind of intimidating when you have a team where people have different choices and different favorites. How do you combine everyone together? So one kind of motion has been to sort of consolidate our resources. And there's sort of 2 approaches here. The first one, which I think is very fascinating, is this framework called Onyx. It's a collaboration between Microsoft and Facebook to create an intermediate representation across different libraries. So what that allows you to do is mix, so transform CNTK models into Caffe2 models and vice versa. So right now it supports CNTK, Caffe2, and PyTorch, and the hope is to have even more frameworks available in the future. So you can train your model in PyTorch, but then deploy it onto Caffe2, where it can be put onto a small device or on an edge device. Well, the other approach to sort of having abstraction that can be used across libraries is to have mixed APIs that you can use with different backends. So Gluon right now supports MXNet, and very soon will support CNTK. And Keras obviously has become kind of the DSL of choice for deep learning. The last thing I'll mention is there are a lot of folks, I think, here as well that really believe that R has a lot of very useful idiomatic features that could be helpful for people to prototype deep learning models. So the very good folks at RStudio have created an interface called Articulate. And it's a very expressive way of writing R APIs to Python libraries. And that immediately sort of spurred this initiative to create R APIs for deep learning libraries. So there's both TensorFlow and Keras developed by RStudio. And a CNTK R package that I developed with a team at Microsoft is also based on Articulate. So the goal for Onyx is pretty broad. We really want to make it the intermediate representation layer for as many frameworks as possible, not just these 3 right now, and allow it to run on any kind of hardware that you have available to you. So that could be GPUs, it could be FPGAs, it could be CPUs, it could even be TPUs at Google if they're interested in that as well. So very excited about this project. We really hope we have more people coming and contributing towards it. The one thing that I do want to think about is, how does this play with other IR frameworks like Weld and other frameworks developed by other companies? I think it'd be very important for us to make sure that we don't all develop our own standards that don't mix and match together. So one sort of example of where this is going is, I think, the Microsoft MLServer package that we released a few years ago. So Microsoft MLServer is currently in 9.2, which has some new additions to it. But the nice thing about Microsoft MLServer is that it unifies many different languages, R and Python primarily, as well as different data sources and different libraries. So in particular, when I joined Microsoft, I came from a company called Analytics, and that was our mascot, Clark. And we had 2 main packages for R called RevelScale R and Microsoft ML. So these are 2 packages that are written in C++, a little bit of Java, a little bit of Scala, and a little bit of C#. And we created an interface from R into these packages and had them available as a computer environment in Spark. So that was pretty fun for us. It allowed us to take sort of existing R code and distribute it across the entire cluster. And then one thing that we spent a lot of time in the 9.0, 9.1 release was to integrate that with Sparkly R, which is the RStudio R API for Spark. So now you can share a session between Microsoft ML server as well as Sparkly R, do everything you do in Sparkly R with Spark ML, dplyr, and Spark SQL, and all of Sparkly R's extensions, which include things like H2O, graph frames, so on and so forth. And then too, we're very happy to release an interface between our Python versions of those packages, called RevelScale Pi and Microsoft ML, into PySpark as well. So we've sort of taken this core library written in C++, C#, and Scala, and made it available as an interface to Python and as an interoperating language with PySpark and Sparkly R. Creating a session is actually pretty damn simple. You just have to define your environment variables for Spark lives. You connect to a Spark session through Microsoft ML Server itself. That's the RX Spark Connect function. And you just pass one parameter saying that I want interop with Sparkly R. And as long as you have a working Sparkly R installation in your driver program, driver node, everything will work just fine for you. So that's pretty awesome. All right, so that's kind of one example of how far you can get with a sort of reusable library across different APIs. Another very interesting package that we've spent a lot of time working on is a Microsoft Machine Learning for Spark package. So this is a package that integrates CNTK learners and OpenCV readers to sort of extend the the Spark pipelines to incorporate other estimators, transformers, and readers. This is available as a package pretty much every framework possible. So you can get it through Maven, you can get it through SBT, through Docker, so on. So you have no excuse not to use it. And we really want to make this as native experience for you as possible. So much so that we've opened up a pull request to incorporate the image readers from ML Spark directly into Spark SQL itself. Right? So you want to add to the community as much as possible. We're very lucky to have Miruna here tomorrow to talk about ML Spark. She's one of the engineers at the team working at ML Spark. Really, really awesome engineer, better person than I am, so make sure you go check her out tomorrow. She's speaking twice, once at 2:40, once at 4:20. And then, I'm going to go this quickly because I'm running out of time here. Our main Hadoop offering, Spark offering in the Azure platform is called HDInsight. And it's an enterprise solution for Hadoop and Spark because we have very good SLAs for it, so you're guaranteed to have your cluster up and running. We have monitoring services, patches, and all that kind of things. But a lot of times for deployment, you don't want to have a big standing cluster all the time. You want to be able to have a on-demand cluster that you can prototype with quickly and efficiently. So we very recently released a toolkit called Azure Distributed Data Engineering Toolkit. It used to be called Thunderbolt, but now it's called this long-winded name. And it's basically a command line interface to launch Spark clusters on Azure Batch. And Azure Batch is a sort of batch-oriented system for creating clusters and VMs in Azure. What's nice about Azure Batch is that it's fully extendable, so you can use any kind of VM we have in Azure, including GPU VMs and soon FPGA VMs. You can also choose low-priority VMs, so things that are at a heavy discount, 80% off, so significant discount than what you would get on a regular cluster. And it's not some sort of hand-me-down cluster. It's not some sort of second-rated cluster. It's a full cluster. So you can customize it all you want. You can install Jupyter, RStudio, Vegas, whatever you feel like install, you can go ahead and do it. You want to make this as extendable as possible, so it'll connect to your data stores of choice, Azure Blob Storage, Data Lake Store, Cosmos DB, even Amazon S3. Creating a cluster is dead simple. It's a simple CLI command to create a batch account and then to create a cluster. You can find the links here, so feel free to take a look at that. That's the main link is this one here, and I add some instructions in my repo here you can take a look at. All right, running really out of time. So I want to talk quickly about what's available in CNTK and Microsoft ML for Spark. So one of the main sort of hindrances that people face with deep learning is that traditional algorithms tend to have a very rapid scale-up motion, whereas you add more data to it, they scale up pretty quickly and pretty well, and they kind of saturate after that. Deep learning, on the other hand, most deep learning algorithms, they have a much sort of less deep learning curve. So it takes a lot more data in order to get good performance out of deep learning algorithms. But one kind of interesting aspect about that is that they seem to kind of unreasonably improve as you add more data. So Google added this really cool paper this year where they sort of saw that as they scaled up their image corpuses to orders of magnitude higher, they didn't reach a saturation point. They still get better performance. So the hard part is for most researchers and most developers, you don't have that scale immediately. So we want to see how can we sort of jump up that curve. So go from small amount of data and still achieve significantly better performance than traditional algorithms. Yeah, actually, looks like this. You guys probably noticed it takes a long time to train deep algorithms. All right, fair enough. So one kind of example of this is if you really do have lots of data, you could train an algorithm from scratch. That could take a long time. So if you have over 1 million images, you can go ahead and do that. If you have a medium-sized data set, what you can often do is, you saw in the keynote, is just chop off the last few layers, which actually have the most parameters because they're all fully connected parameters to each other, and then retrain those to your data. So hopefully your neural network has learned some abstract features that will be reusable for your corpus. Obviously, if you train it on cats and puppies, and now you want to predict X-rays, lesions, something like that, you may have to train it a bit deeper, but usually this works out pretty well for many applications. If you have very little data, so it's just in the tens or hundreds, you can really just do the last layer. Just cut the last layer and then retrain anything on top of it. It need not even be a softmax or a neural network. It could be a random forest algorithm. It could be a decision tree, so on and so forth. So let's see an example of that. So here's how you do it in ML Spark. So this is in a Spark session. We have a function in ML Spark called model downloader, and it will download a pre-trained CNTK model for you. It could be a Caffe2 model that you convert to CNTK or a PyTorch model as well. And then we're going to chop off the last layer. So that's the 18th layer there. And then we're going to add on a new transformer. So this is from the ML Spark package. You're going to use the train classifier method to train a random forest classifier from Spark ML pipelines. So hopefully what's cool about this is that this fits directly into Spark ML pipelines as you already have. Nothing weird or quirky about this. So you can use, we're just adding a new estimator class that you can use with additional algorithms. All right, let me show you a slightly more involved example. So this actually takes a look at our new toolkit. This is the Azure ML Workbench. And I'm struggling a little bit with the resolution here. Is that kind of visible to you guys? Right. Well, if I'll be around all week, so if you want to see it more closely, you can. And also come to our booth. We have a booth, so you can come and see it in person as well. So Azure ML Workbench provides a consolidated workflow for doing experimentation, deployment, and model management. So actually, I'm going to skip to the end of this session. This is actually the sort of the validation section. So after you train your model, here's how you can look at it. And I'll show you how you can train your model in a second. But we have the capability to run Jupyter notebooks that are hosted locally but can connect to a remote kernel. So if you look, if you want to choose a kernel, you can choose a kernel that could be any local kernel you have locally, or it could be a remote cluster, a remote VM, even a Docker image somewhere else. All right, and what I'm doing here is I'm sort of showing you the trained algorithm. This is a multi-classification problem, and here are our results. So it's not something too crazy, but it's just nice that it's in a consolidated workflow here. The very interesting part about this is everything you can develop prototype locally, so you can use VS Code tools, or you can use any editor you feel like, and then you can deploy all these algorithms, all these scripts onto any cluster you want. So you can deploy them into, in this case, I have an HDI Spark cluster. I can run them all in there, and you can connect to any sort of resource you have in Azure for doing so. We provide a sort of management system to look at how your runs perform. So in this case, this is from today. I ran a few models. You can see how long each of them took, some learning curves on them, the accuracy of these models. And you can dig deep, as far deep as you want, into these different runs. You can look at the errors, the output, so on and so forth. All right. Yes, please feel free to come down to our booth and film me if you want to see it in more detail at any point in time. All right, the other application that I want to talk about is for language. So what I'm going to do is kind of skip towards here. What we're going to try to do is a kind of a quirky sequence modeling example. So what we're going to do is we're going to take a pair of data. So our data is going to be of code commits. So that's what you've changed in your code from your last iteration, as well as some message. And the message is going to be anything that you have written inside the code. It's inline code, any git commit message, any issues that you've submitted that relate to that git commit, so on and so forth. So that's going to be our training corpus, and we're going to try to create a natural language model for predicting the next natural language word from that input sequence. So what that means is that it'll get some code commit, which will be some tokenized collection of tokens from your code commit. We're going to train a sequence model with attention. So it's going to try to train a model for predicting the next most likely word given the input sequence, while keeping attention scores to different parts of the input sequence. So here's an example of what it might learn. So given input sequence, it might give you a message saying, add this function for doing sums along the row axis. All right? This sounds kind of weird and stupid, but it's actually kind of useful. So I got inspired from this bot that we released for Stack Overflow, where you could use Stack Overflow to sort of be your assistant for creating programs. And here's kind of a little bot that helps you create git commits in a more meaningful way than most people do. All right, so I run out of time, so feel free to pull me out and talk to me about it afterwards.
For Q&A, raise your hand if you have any questions. I'll bring the mic to you.
No questions?
No questions?
I could have kept going.
All right, you have 2 more minutes then.
Like, no questions, nobody? All right. OK. All right, so basically what our model does is it tries to predict from an input sequence of code what is the summarization for that code in natural language. So one way that could be very useful is to have an automatic git commit messenger tagger for you. So in VS Code, I created a little bot where you ask for a git commit generator, and it'll generate for you the most meaningful git commit message for you. I found it pretty useful because when I was parsing through that data set of git commits, I saw very few folks that gave meaningful git messages. So I thought this was pretty useful. I think part of the goal of having standardized tools is to make sure people can collaborate well with each other. So this could be useful. The last 20 seconds. Yeah, come talk to me afterwards. I can do it in 20 seconds. All right.
Any questions now? All right, if not, let's give Ali a big Round of applause.